Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dikish Farizi bin Jeffrey. Our group will present about carboxylic acid, this is our chapter 8 in CHM207. So this is our group member.
Hi, I'm Ahmad Fakrin Haikal.
Hi, my name is Syed Muhammad Izzat bin Syed Anwar.
Hi, I am Danish.
My name is Corina Ana Ustinikau.
First thing first, what is carboxylic acid? The functional group of carboxylic acid is RH double bond or OH. And how do we name carboxylic acid? By change E at the end of alkane into oic acid. So here we have 4 examples of carboxylic acid, which is formic acid, methanoic acid, acetic acid, and lastly ethanoic acid. There are few physical properties to determine carboxylic acid. First order, methanoic acid has a pungent odor. Ethanoic acid and propanoic acid have strong vinegar smell. Lastly, the higher members of the homolog series, acid with 4 to 8 carbon atoms, have a very strong unpleasant odor of rancid butter. Second, we have boiling point. Aliphatic acid with 1 to 10 carbon atom are liquid. The boiling point increases with increasing relative molecular mass. Carboxylic acid have higher melting and boiling point than alkanes of similar relative molecular mass. The reason is carboxylic acid can form hydrogen bond with one another in the solid and liquid states. Lastly, we have solubility in water. Carboxylic acid are fairly soluble in water due to hydrogen bonding with H2O molecule. Second, the solubility of carboxylic acid in water decrease as the relative molecular mass increase. For example, propanoic acid is very soluble in water. Butanoic acid and pentanoic acid are soluble in water, but hexanoic acid is only slightly soluble in water.
Now let's move on to the uses of carboxylic acid in commercial, industrial applications and living systems. Carboxylic acids are compounds that occur naturally in various stages of life cycles. Living organisms, Krebs cycles, fermentation processes, and geological processes. All can be produced in laboratories or on a large scale. Synthesis through oxidation reactions of aldehydes, primary alcohols, and hydrocarbons, oxidative cleavage of olefins, base catalyzed dehydrogenation of alcohols, or hydrolysis of naturals, esters, or amines. Organic acids serve important and diverse functions in modern society as indicated by their numerous applications in medical, agriculture, pharmaceuticals, foods, and other industries. Carboxylic acid and derivatives are used to make polymers, biopolymers, coatings, adhesives, and pharmaceuticals. They can also be utilized as solvents, culinary additive, antibacterial agents, and food laboratories. The first one, I would like to talk about commercial and industrial applications. The first is food industry. First acid that we use in food industry is acetic acid. Acetic acid, known for being the primary ingredient in vinegar. Acetic acid is frequently used as a flavoring and preservative. The second one is citric acid, used in drinks and candies as an acidulant, tastes therapeutic actions. Next is polymer industry. Terephthalic acid is a necessary monomer in the synthesis of polyethylene terephthalate, which is extensively utilized in synthetic fibers and plastic bodies. Adipic acid necessary for the production of the synthetic polymer nylon. Next one is cleaning agent. Acid that being used is acetic acid because it can remove grease and mineral deposits. It is used in a variety of cleaning solutions. The second acid is formic acid, used as a disinfectant and in cleaning products. Second last is agriculture. Herbicides. Dichloroprophenolic acetic acid and other carboxylic acid work well as herbicides. Second one is feed additive. To preserve animal feed and encourage growth, a variety of carboxylic acids are utilized. Last, for commercial and industrial application is textile industry. Acetic acid also been used in textile industries because it is used in dyeing procedures to regulate pH and enhance dye absorption. Now, we're gonna move on biological system. First is metabolism. Essential to cellular respiration, the citric acid cycle, also known as the Krebs cycle, involves carboxylic acids including succinic acid and citric acid. Long-chain carboxylic acids are essential for membrane structure and energy storage in the metabolism of fatty acids. Next is protein synthesis. Amino acids. Essential to the synthesis of protein, several amino acids, including aspartic acid and glutamic acid, have carboxyl groups. Next one is biosynthesis of other compounds. Vitamins and hormones. The manufacture of some vitamins, including vitamin C, is aided by carboxylic acid. Second last is cell signal. Prostaglandins made from fatty acids. These molecules are essential for signaling activities such as inflammation. Last, for biological system is structural rules. Hyaluronic acid, a polymer with carboxylic acid groups, is necessary for cartilage and connective tissues to be hydrated and structurally intact.
Carboxylic acid got 6 reactions. Number 1, salt formation. Number 2, reduction to alcohol. Number 3, formation of acyl chloride. Number 4, formation of ester. Number 5, formation of amide. And lastly, formation of acid anhydride. Salt formation. In salt formation, we have 2 reactions. Number 1, neutralization. Carboxylic acid undergo neutralization reaction with base to form carboxylate salt of carboxylic acid and water. Propanic acid sodium propionate is an example for this reaction. Second, reaction with electropositive metal. In this reaction is formed carboxylate salt of carboxylic acid and water. Hydrogen gas and carboxylic acid salt are produced when reactive metal. Metal with a high electropositiveness is react with carboxylic acid. Magnesium ethionate is an example for this reaction. Formation of acyl chloride. Acyl chloride is produced when carboxylic acid combined with phosphorus chloride, sulfur dioxide oxide, or phosphorus trichloride at the normal temperature. The reaction mixture is heat when benzoic acid is included. This picture is an example for this reaction. The third reaction is called reduction to alcohol. LiLH4 in a dry ether is a reducing agent. Carboxylic acid is reduced by primary alcohol. As you guys can see, both picture is an example for this reaction. Fourth reaction is called formation of ester. An are heated together with a small amount of concentrated sulfuric acid. The aroma of simple ester are aromatic. They serve as flavoring adjunct in the culinary sector. Benzoic acid and ethyl benzoate is reduced in this reaction. Formation of amide. Direct synthesis of amide from carbolic acid is possible, although the yield is low. Using acid chloride is a better way to synthesize amide. Ammonium carboxylate are produced by the interaction of carboxylic acid with ammonia. When heat in the presence of the free acid, the hydration takes place to generate the main amide. The last reaction of carboxylic acid is formation of acid anhydride. In this reaction, we have two reactions. Firstly, reaction of sodium carboxylate plus acid chloride, and second, the hydration. Acid anhydride is also formed when a carboxylic acid is heated with phosphorus pentoxide to the hydration reaction. The water is absorbed by P2O5 to form H3PO4.
Benefit as we can reduce brain inflammation when risk of heart attack. Cyclic acid are good antis and promote skin renewal. Food preparation. Acetic acid during preparation is still shelf life of food. Citric acid are prevent spoilage and extinction of flavor. Household uses acetic acid effective and ecosystem cleaning agent. Citric acid remove limb scale and standard industrial purification. Acetic acid are key in producing humor and textile. Formic acid is in a literal process and as a present discussion. Carboxylic acid are organic compound with a complete group COOH. Source in a organic waste or decomposition of plant and animal matter. Fermentation process and laundry and compost heaps. Common carboxylic acid in what residual compounds like acetic acid, lactic acid, and carboxylic acid. Mechanism: leaking of carboxylic acid from organic waste into water bodies. Breakdown of organic matter release acid into soil and water. Effect: lowering of pH river, lake, and stream. Negative impact on aquatic life like fish, dispersion on nutrient cycle and water quality. Recommendation: benefit of carboxylic acid. First, it's for our health. Two, it's for food preparation, colorings. Three, is household uses and used industries application.
For the conclusion, we can define by the existence of carboxylic group. Carboxylic acid are known for their acidity, hydrogen bonding, and reactivity, which can result in the development of significant derivatives such as amide and ester. The substances are essential for industrial use, such as the manufacturing facility of polymer and paramechanical, as well as a biological process, including the synthesis of fatty acid and amino acid. Carboxylic acid, such as citric, formic, and acetic acid, show their many functions in daily life due to their higher boiling temperature and water solubility. Carboxylic acid are an important area of study in organic chemistry since they are both flexible and necessary.